Good morning, guys. This is a major topic at Maths GCSE, solving simultaneous equations. There's different ways we can do it. We can do it with a graph, we can do it algebraically, and today we're going to be looking at doing it algebraically. Believe it or not, we've done this before using graphs. You may not remember it, but the solution to two equations is where they cross, where their graphs cross. I always like to introduce it using a method like this, or an example like this, where you go to a dodgy cafe and there's no prices on the walls, and you order 3 coffees and a tea, and the person serving you tells you that that's going to cost £7. So I'm just going to write that down as an equation. So 3 lots of whatever coffee costs plus 1 tea. Now remember, we wouldn't put the 1 in front of it, is equal to £7. Okay, and the next person behind you in the queue orders 1 coffee and 1 tea, and that just costs £3. Okay, so let's just look at the first order. Now let's look at the second actually. Think about how many different things the coffee could cost and the tea could cost that would equal £3. Well, coffee could cost £2, tea could cost £1, coffee could cost £1.50, and so could the tea. The coffee could cost £1.10 and the tea could cost £1.90. There's so many different combinations that would equal 3 that we just can't solve this equation. There's too many unknowns. There's 2 unknowns in a single equation, and therefore we can't solve it. And on its own, it's the same with this equation. There's 2 unknowns, 1 equation. We can't solve it. There are almost an infinite number of things that these could be. Okay, well, there are an infinite number of things these could be if we if things could be less than a penny, or even negative numbers, which wouldn't make sense in this context. But together, with there being 2 equations and 2 unknowns, we can solve these simultaneously. And simultaneous means at the same time. Okay, so here's the method of doing it. It's quite formulaic. I'll talk about the understanding behind it as well, but if you just get this method down to a T, you will find no simultaneous equations questions a challenge, really. Okay, and we're going to practice it that much over these next couple of pages that it should just be second nature and just sort of flow automatically. So the first thing I would encourage you to do is label your equations 1 and 2. I've started by doing that for you in the pack, but as you go on, that scaffolding disappears. Okay, so labeling our equations 1 and 2. Now, what we then need to look for is whether any of our variables are the same, in other words, have the same coefficient. These ones don't have the same coefficient, number in front of them, in other words. However, the t's do. Okay, in both cases, only 1 t was ordered. Okay, so when you've got that, when you notice that the variables are the same, the coefficients of the variables are the same, what you can do is eliminate that variable. And you have to think carefully about what you could do with these 2 equations to eliminate that variable. And in this case, it's going to be taking away the 2 equations. Okay, we're going to do equation 1, take away equation 2. And what that would do, if you think about that in the shop context, the cafe context, is we're finding the difference between these 2 orders. And the difference is 2 coffees. That's the only difference between these 2 orders. And the difference in price, 7 minus 3, was £4. Okay, so we've just done that subtraction. The t, we took away this t and it disappeared. We've eliminated that variable, and that's why this is called the elimination method. So now that we've worked out that 2 coffees equal £4, we've got a little equation there. It's not really one that we need lines down the side to solve, but I'm going to do it just for method, really. Little equation we can solve, divide by 2, so 1 coffee is £2. And now once you've found what one variable is, you can then go back to just one of your equations, either is fine, and substitute this in to find out what the other one is. So I'm going to substitute this into equation 2 because it's a much easier equation. And this is why we circle the 2 equations at the start. It's very easy to refer to which one we're talking about. So C is now 2, so we've got 2 plus T equals 3, so T must be 1. Okay, so coffees cost £2, teas cost £1. Okay, let's do another couple of examples on these ones below. So remember to keep explaining what you're doing. So looking at this one, they're already numbered, and our coefficients of x are the same, both 1. Okay, so I'm going to subtract these to eliminate the x's. Now, it doesn't really matter which way around you subtract them, but sometimes there's a more obvious way to do it. And in this case, both of the remaining things are bigger in equation 1. So I'm going to do equation 1 minus equation 2. So that would be x minus x, which would be 0. 6y minus 3y would leave me 3y. And 53 minus 38 would leave me 15. So if 3y is 15, if I divide by 3, y must be 5. That's one of my answers. Don't forget though, I've got to find the other answer, I've got to find what x is, and to do that I'm going to substitute y equals 5 into one of those equations. Doesn't matter which one, I'm going to go with equation 2. So x, I still don't know what that is. 3 lots of y is 15, x plus 15 equals 38. And then I'm going to solve that equation by taking away 15, and that will give me 23. Okay. Now, moving on to question B. We've got 2a in the first equation, we've also got 2a in the second equation. So they have the same coefficient. So again, to get rid of the a's, we're going to subtract one equation from the other, but this time in the second equation, the other two things are bigger. So we're going to do equation 2, take away equation 1. 2a minus 2a would be 0. 4b minus b would be 3b. And 42 minus 24 would be 18. So when we divide both sides of that by 3, we get b equals 6. We're then going to substitute that back into one of the equations. We have to do less with it if we put it into the first equation, so I'm going to put it into the first. So 2a plus 6 equals 24. The equation solved there. We're going to minus 6, so 2a equals 18, and then divide by 2, so a equals 9. Okay. Right, have a go at the rest of these yourself. In all of these questions, you've got 2 of the same variables just ready to go. Just be careful with negatives. I'll just go through one of these ones with negatives before you do this. Let's go for question F. Okay, so first thing to say about this one is that the equations haven't been labelled yet, so let's start there. Right, I've got 3i in both of them, so I'm ready to eliminate the i's. Now, which of these is bigger? You might be tempted to do equation 1 take away equation 2, but actually the negative 2j is bigger than negative 6j, and I would always look at this rather than the number at the end. Okay, so in this case I would actually do equation 2 take away equation 1, because I don't want to be messing around with negative numbers with my variable at the end. Okay, so 3i take away 3i is 0. What's negative 2i take away negative, sorry I said I, j, take away negative 6j. Okay, just have a little think about what that'll be. So here, this could become a plus. What's negative 2j plus 6j? And that'll be 4j. And 23 minus 27 is minus 4. So j is negative 1. And most of the time when people make mistakes on simultaneous equations, it's probably down to something to do with negatives or something like that. Okay, so we're then going to sub that in to either of those equations. We're going to go with equation 2. Be careful here substituting a negative number. So 3i minus 2j. Now, 2 lots of negative 1 are negative 2. So this is 3i plus 2 is equal to 23. So 3i must be equal to 21. So I must be 7. Okay, so just watch out for negatives. They can cause you to go wrong here. Pretty much all the answers to these questions are sensible numbers, whole numbers, or there might be the occasional fraction, which is a 0.5 or 0.25. But in a non-calculator simultaneous equation question, 9 times out of 10, they will just be very sensible answers. Okay, you have a go at the rest, and then press play when you're ready to see the answers. Okay, there's the answers to the first few questions. Scroll down so you can see the other ones. These are all uploaded via PDF as well to homework tasks. Okay, let's have a look at the next page.